get into some hands-on, real-world application that is way more than just a toy example in this workshop. So can't wait to just dive into it. But before we get to that, we will have our organizer Mahan to give us a brief intro on AI Summit. The stage is yours, Mahan.
Thank you so much, Kevin, for a brief introduction. Welcome, everyone, to the AI workshop. My name is Mohan. I'm representing the Tech Equity AI. It's a community-focused AI nonprofit organization that democratizes access to AI knowledge and applications. We are honored to have a vision of democratizing AI and what we do through a series of AI summits. And in fact, the first AI summit happened on March 30th at Sunnyvale in the heart of Silicon Valley. And we were honored to have a great number of speakers from industry leader companies and corporate and startups and academic institutions. The next AI Summit happened on October 26th, and we are honored to open this summit for volunteers, those who would love to volunteer for AI Summit on October 26th. Please contact Sheena. Sheena is going to put an email on the chat. Please contact her, and we will definitely contact you in order. So a little bit about AI Summit on October 26th. We have 4 areas of topics that our speakers are going to focus on. Use AI, build AI, and responsible AI, and C-suite AI that we inviting the industry leader, tech AI and robotic companies, CEOs to be our speakers. And at the same time, they showcase cutting edge and beginning edge products for the visitors. We have 4 areas of audience, so business, established companies, and emerging startups, and we have community attendees, AI enthusiasts, academia, academic institution, and investors. We tackle 4 areas in our next AI Summit: keynote, AI showcase, and panel and workshops. And we are honored today to introduce you to our past and future speaker, Akshita. She is going to give us the sneak peek what workshop means at the AI Summit through a series of workshops that we establish between our AI summits. Back to you, Kevin. Thank you so much for this opportunity. Please go ahead and continue.
Thank you, Mahan, for the introduction. Before we jump into the workshop, I want to remind everyone that we have a Q&A function where you can ask questions about the workshop or about AI Summit in general. And at the end, we will be picking up some of the questions to answer. So please definitely shoot any question that you have. And if we happen to go over time, we actually reserved extra 30 minutes to this session to answer extra questions if we weren't able to get it in the hour. And so if you have time, please also stay behind for that as well. Now, let us go into our workshop. Let me introduce our workshop host, Akshita. Akshita is a senior software engineer at Nvidia working on perception for autonomous vehicles. Perception is a fundamental block that allows autonomous vehicles to understand the world that's around it. It's a multivariate problem tackling accuracy, robustness, multimodality, latency, efficiency, and of course, safety. She specializes in deep learning and computer vision and has previously worked at Google, Meta, and Amazon as software engineer and applied scientist. Let's welcome Akshita's workshop, Building Your Own Mini-ChatGPT API. Akshita.
Hello, everyone, and welcome to Introduction to Prompt Applications. This is a mini workshop series aimed at helping you make your own mini application using LLM APIs. For this course, we will mainly be sticking to LangChain as our framework, but I will mention and touch upon a few other frameworks as well. The objective of this workshop series is twofold. First, I would like to get you the tools to start building your applications. For this, we have proposed 2 information workshops. The first one is today, where I will give you an introduction to the history of language models. We will look at what a prompt is and some good techniques of prompting. We will then start off by building a simple LLM app and expanding it using chaining prompts, and eventually serving it on the Streamlit app. In the next information workshop, we will start by looking at fine-tuning an LLM and why people choose to use RAG frameworks. We will then look at adding memory to LLMs to support these RAG frameworks. And if we get time, we will add external tools such as booking.com and other commercial tools to our existing applications to make them much more useful. And we will also see why RAGs sometimes fail and what people are doing to resolve these issues. However, the main idea is that we want you to start building your own apps and ask questions along the way in an interactive manner. So for this, we have a GitHub repo where I encourage every one of you to start issues and ask me questions over there. Do ask us questions on the Meetup app and keep it as interactive as possible. Just before I start, I would like to point you to this particular resource. So this is the code base. This will also be shared to you. The slides will be shared to you at the end of the workshop. This is the code base that we'll be using today. This code base has been inspired and in parts borrowed from different resources, and all the resources are listed down over here. This particular page also has commands and instructions on how to start with your Python notebook, how to register your OpenAI account, and just get started with building this code base. There are some caveats in today's demos, and they are explained in great detail over here with examples on how you can modify them. Please feel free to ask me questions about this as well. One other thing, the application that we'll be using to stream our LLM application is the Streamlit app, but that tutorial in itself is going to take like half an hour or 1 hour of explanation. So I have linked it over here, and we'll be seeing how to use it rather than the entire framework, but I definitely encourage you to go and check out this video because this is pretty good. Having said that, let's get started with today's workshop. How did we get here? It all started with the question, what comes next? When given an incomplete sentence, we wanted the models to predict the next word. One of the first algorithms to tackle this was the n-gram model. Given an input sentence, we look at the n-1 words of that sentence. For example, let us take n to be 3. Here, the last 2 words would be ChatGPT is. The next step is to go through our training data, or in this case, the paragraph, and search for this incomplete clause. We count the number of occurrences of the clause and determine the most frequent one. Here, we see that ChatGPT is the most common clause in this paragraph, and therefore we select as our answer. One of the downfalls of this algorithm is that in most cases, it doesn't use the entire sentence. If n is too small, say the last 2 words, the answer might not be suitable. However, if n is too big, we might not see such instances in our database altogether. So, how do we increase n? For this, we jump into the next generation of language models. RNNs, or recurrent neural network. Let us look at the model in an image format from the previous example. Here, the blue circles represent the input, the red, the algorithm or the model, and the purple is the output, meaning the next word of the sentence. Now, let us break it down. Let there be just one input which gets passed on to the algorithm to give the output. Let's see how this would look like if every word of the sentence had its own model. Basically, irrespective of the sentence, if we have a word that we want to predict what is next. You must be thinking, how is this helping us learn context from previous words of a sentence? The idea is simple. For each word, we take 2 outputs of our algorithm. One is the next word or the prediction, and one is the hidden state. This hidden state is a representation of whatever it has learned from the sentence so far. Since we call this mechanism over and over again, we call this algorithm as recurring neural networks. The great thing about RNNs is that now we can read entire sentences no matter the length. However, there is one drawback. Since the model runs sequentially, the predictions towards the end of the sentence have greater weightage and is more dependent on the more recent words. Sometimes words earlier in a sentence can give much more information. We need a mechanism to pay attention to the parts of a sentence that can give us the most information. For this, we move on to our next model, the transformer. The key idea behind transformer model is self-attention in an input. To understand attention, we must look at the sentence in a matrix format, where every word sees every other word in the sentence. We pass this matrix into an algorithm, and based on the computation of the matrix, we decide which words are worth attending to or focusing on. Here, the words that are highlighted in purple have the most weightage and they're selected. This attention information is passed along with the words through the next part of the model. The model then predicts the output. Here, the output is not just limited to predicting the next word, but it can actually output entire sentences. The capacity of this model is no longer limited and it can actually make meaningful inferences. For instance, if you ask this model, "Hi, how are you?" it can say, "Hi, I'm fine, thank you." So, what are LLMs? LLMs stand for large language models. The key idea of LLMs is to take advantage of the transformer model and use it as a building block. When you type a prompt into the chatbot, it extracts information and decides which words and phrases to pay attention to. This is called encoding. It then decodes this information that it has stored, and it gives you all the answers that you need. Now that we have an understanding how LLMs process and generate responses, let's actually explore how we can shape and refine these outputs through the art of prompt engineering. So, what is prompt engineering? Well, let's think about it. Prompting essentially means the action of saying things to persuade someone to do or say something. Similarly, in prompt engineering, we create queries with task description, information, examples, instructions. We pass it to the model, in this case, a pre-trained LLM, to get the desired output. Having said that, let's take a deeper dive into the components of a prompt. A prompt has two main parts. It has an instruction telling the LLM what to do, and it has some form of input data. To make the prompt better, we might add additional context. We might also add an exact output indicator so that the model knows the format of the output to be expected. Let's see an example. So for today's demo, the thing that I'd like to make is an application that plans a getaway. So if you give your application your current city and the number of days you have for a holiday, it will suggest a destination along with the itinerary. Keeping that in mind, one of the first prompts that we'll see is this. Suggest a weekend getaway place near the city of my choice. This is the instruction. The input data could be the city, which is San Francisco. Sometimes you want to give it more context. For instance, suggest places near San Francisco in winter. And finally, you give an output indicator, which is the getaway place. OpenAI actually has guidelines, and I've linked it over here on how to make your prompt better. Here are some things that I actually found useful. Use the latest model. So by default, OpenAI gives you ChatGPT 3.5, but this model dates back to November 2022, meaning that this model doesn't have information after that. It hasn't been trained on any data after that. For today's demonstration, we don't really need a model that is up to date. And when you're trying to play around with prompt engineering, you still don't need something that's very up to date. But when you're finally making applications for your business or for other purposes, do keep in mind that you might want to use the latest model based on your application. Structure your instructions using tokens such as hashes or quotation marks. Like the previous example, I have separated the prompt from the information, the input data, the context, the output indicator using hashes. This actually makes it easier for the LLMs to parse your text, and you will definitely get better responses. Be specific and detailed. Give examples. Another thing I'd like to add here is LLMs use positive examples much more than negative examples. So for instance, if you are trying to get the prompt to do something, it'll be better if you tell it what to do rather than giving it examples of what not to do. Finally, use zero-shot, few-shot, and fine-tune approaches. Like I said earlier, we will look at fine-tune approaches in the next information workshop, but today I will give you a brief explanation of zero-shot and few-shot. So what is zero-shot versus few-shot? Well, as the name suggests, in zero-shot, you simply tell the LLM what to do without much context. For instance, if you give it a question, a juggler can juggle 16 balls, half of the balls are golf balls, and the other half of the golf balls are blue. How many blue golf balls are there? You might give it some context or an output indicator, or in this case, like an instruction saying, let's think step by step, which will help it to give you better answers. But that's probably it. The difference between zero-shot and few-shot is that in few-shot learning, just before you ask a question, you give it some examples. In this particular case, before asking a question about the juggling balls, the prompter has actually given one pretty detailed question. In theory, few-shot does seem to work better than zero-shot, so that's something that you can keep in mind. Now that we have somewhat of an idea of like what a prompt looks like, let's see how it looks like in an actual demo. So for that, we will be installing the prerequisites today. I'll show you how to register your API keys. We will look at how prompts are run in real time. Then I'll explain prompting templates, prompt chaining, introduction to memory buffers, and we'll tie all of this together on the Streamlit app. So let's get started. Okay, so the very first thing that I'd like you to do would be to install Python Jupyter Notebook. For this, I think I already have it installed, but you can simply just go to your terminal and do pip install notebook. It will take some time, but it should get there. Yep, for me, this has already been installed, so that's great. The next thing, so what Jupyter Notebook is, it's like an interactive environment where you can just put in commands and get your output right there on the fly. It's really a great resource for you to learn things and as you're building them. So in order to start it, you can just type Jupyter Notebook in the directory that you wanted to start. So I just typed in Jupyter Notebook, and in a while it should just run and open up a page on my browser. While that's happening, let's get started with, oh, it's right here. Perfect. While that's happening, let's get started with the next part, which is getting your, registering your OpenAPI account and getting your API login key. So for that, we go to the OpenAI page, go to products. Instead of ChatGPT, go to API and log in over there. If you don't have an account, create one. I think I created it and I'm logged in. Once you're logged in, you would want to come over here to the top right corner, go to your profile. And right now they have user API keys over here, but they're going to become legacy. So they're replacing it with project API keys. What this key does is it gives you access to the ChatGPT models, and you can call it in your code by using this key. You will have to pay for this, but OpenAI gives you a $5 credit in the beginning to try and test out different things. And later on, you can, based on your usage and on the website, you can add more payment methods. So the way you create your key is by creating a new secret key. You can, oops, I have a key, so you can just write the name over here, create your secret key. Do copy this because you will lose it as soon as you click done, and save it somewhere. I don't particularly need this key because I have my key right now, but yeah, so that's how you create your key. The one place that I do store my key is right here. I have a file which says registeredkeys.py. And over there, I just store it as OpenAPI keys equal to, and I just paste my key right here. So 1 second. Terminal. Okay. So, okay. I will copy my registered API key right over here. So now that we have our Jupyter Notebook, we have the OpenAPI key. We want to install the rest of the requirements. You can get them over here. Okay, I'll add them over here, but you can the requirements will be in a file called requirements.txt, and I will just copy paste that as well. CP requirements.txt, and I'll copy that here. And the way I install it is just pip -r install requirements.txt. Oops, it's the other way around. Pip install -r. And basically, we're installing OpenAI, LangChain, Google Search, and Streamlit. So that's all done over here. Now we will go on to the Jupyter Notebook. And over here, we already have everything that we need to get started with the demo. So the way we start a new notebook is just by going here, clicking Python 3 kernel. Okay, so just before we get started, we have our OpenAPI key, but we want the environment to register this key. The way we do that is that, 1 second, we use OS, and we have the registered key in registeredkey.py, the library that we created, and we just register it over here. So that should work. Now, in order to run a prompt, we first need a model, an LLM model. The way we get that LLM model is by bringing it from LangChain. This OpenAPI is a class, and we create an object of this class by simply calling it over here. This is our LLM model. We might want to set the temperature. Now, what temperature is that it's a measure of randomness. It's a value between 0 to 2, where 0 is very deterministic and 2 is completely random. I've set it as 1 because we do want varying destinations based on, we want to see options where as to where we want to go. So I create my model using that. Then the way we want to get our prediction from the LLM model would be to do prediction is equal to LLM. We want to invoke the LLM with our query or our prompt that we saw in the slide. So I'm just going to copy paste the prompt from the slide. Okay. And then finally, I'm going to print the prediction. And hopefully this should run. Let's just wait. Okay, so from San Francisco, it's taking me to Sonoma County. Now, I have a bunch of information over here. And for this particular application, I just need the destination. I don't need like a fancy description of it. So I will just make my prompt a bit more specific. And for that, I will just modify the prompt by a bit by saying only output the name of the place. And hopefully that should work. And now it's taking me to Yosemite. Nice. The next thing we want to do is prompt templates. So what are prompt templates? Prompt templates are just what they sound like. We create a template from a prompt where certain parts of the prompt can be modified at runtime. If you're familiar with Python format string operation, the prompt template is essentially that. In order to use prompt templates, we need a prompt template library. we are going to create an object of prompt templates. Here we're going to have an input variable city. This allows us to use the same prompt over and over again, but with different input variables. And in the template, the part that we want to replace, we just surround it by curly braces. So we could do that over here. And then the way we create a prompt is essentially the same as Python formatting, which is just prompt template format, and we will do city is equal to San Francisco. Let's go somewhere else. City is equal to Pittsburgh. And then we will invoke again. Prediction will be LLM.invoke, and we'll invoke it using the prompt. Prediction. And let's run. Now it's taking me to Ohio Pal. Nice. Okay. Another great aspect of prompting is that we can have multiple inputs and not just one. So for instance, if it's not just a weekend getaway, but we want like a specific number of days, we can specify that. So instead of a weekend getaway, suggest an X-day getaway near the place of my choice. And let's say I want a 5-day vacation near Chicago. Let's see. Door County. Great. The next thing that we're going to look at is prompting chains. One of the questions that I get asked when I talk about prompt templates is why not just simply use Python formatting? This is because we want to use LangChains. What LangChain does is that it makes a chain of objects of each prompt template, allowing it to be appended onto a list of chains. Now, the LangChain framework is really powerful because it allows these chains to be run in a sequence where the output of one prompt can be used as an input to the next prompt, creating a pipeline. So in order to see that, we will look at an example where once I have the destination, I want to ask the LLM to predict an itinerary or suggest an itinerary for me. So for that, what I want to do is I want to import two more libraries, which is import LLM chain and simple sequential chain over here. Then I will first create my destination prompt template, which is what we've been looking at so far. From the template, I will create a chain object. The way I create a chain object is just by calling this LLM chain class, passing it the model, and passing it my current template. Similarly, once we have this destination, we want an itinerary chain. We can create an itinerary chain by putting this based on the destination and days suggest an itinerary, and we create an itinerary chain. The way we append this into sequential order is by using the simple sequential chain object. For that, we create a chain and we do simple sequential chain and just add all the chains that we want to append one after another. It doesn't have to be just two. The way we call this is instead of invoking the model directly, this time we invoke the chain. So let's see. To get the final content of the itinerary, we will call the chain and we will invoke it with the first input, which is the city of our choice. Now, let's say we want to go to New York, or somewhere near New York. Okay, this is what I was talking about. Now, in the upcoming LangChain libraries, we will no longer have this LLM chain. They've made it more sophisticated with a pipeline and a runnable sequence. Information about that and like this particular example on how we can do that is over here. I'm just using this LangChain thing because it's easier to explain it using an object rather than a piping mechanism right off the bat. So that's that. Now that we have the content, let's see what the content is. I forgot to print it. Okay, so we have an input of New York and a weekend destination. It is taking us to the Hamptons and yep, it's given us a pretty decent itinerary for somewhere in the Hamptons. Okay, now one thing that we haven't done or we can't do is set multiple input variables to a simple sequential chain. For instance, just like before, if we didn't want a weekend getaway, but like a multiple day or a variable day getaway, how do we achieve that? A simple thing that we can do is use sequential chains instead of simple sequential chains. And what that would look like is something like this. So we have the same prompts, but this time we're also inputting the number of days. So we have the same destination prompt, but here the input variables are the cities and days. And it's the same prompt as before, suggest a X day getaway place near the city of my choice. We create a chain object out of it. We have an itinerary prompt where based on the destination that was predicted before and the days that we have, it's going to suggest a detailed itinerary. We call this chain by using sequential chain instead of simple sequential chain, and we give it multiple input variables instead, the main multiple input variables. The way we finally invoke this is like this. Unlike the previous time where we can just give one input, we need to create a dictionary of all the inputs that we have and pass that dictionary into the when invoking the chain. You see that I've added strips to the results of the E2E chain. That's because if we come here, we can see that there are a lot of different end of line characters that we don't want in our final application. So that's just for that. So now that we have that, we can call this plan, we can get away. And let's say we want to go somewhere near, let's just keep it San Francisco. Oh yeah, actually I don't need a dictionary here. San Francisco. And I want like a 7-day getaway. Okay, and let's just run this. Okay, so it's asking me to go to Napa Valley for a week, really. Okay, cool. The last concept that I like to touch upon is memory. So if you've ever used ChatGPT, you will see that ChatGPT actually remembers a lot of context from your conversation. For instance, if you ask who played Harry Potter in the Harry Potter franchise, it will say Daniel Radcliffe. But then if you ask it what is his birthday, it will infer that you're talking about Daniel Radcliffe and it will remember the previous conversation. By default, lang chains do not have this functionality. To show you that, let's just create one simple chain, which is this LLM chain, the same destination prompt chain, and we'll invoke it, but this time we will check out the memory and see that there's actually no memory there. So how can we have like a simple buffer memory to hold your conversation? The idea is pretty simple. LangChain gives you a very easy library, which is conversation buffer memory. This time, the only difference is we create an object instance of this memory by just invoking this library. Then when we're creating our chain, we pass the memory as well. So instead of just the model and the prompt, we pass the memory object as well. And finally, this time when we ask it multiple queries, we will see that that the LangChain is actually stored the history in its buffer. So for instance, we have, if we print the memory buffer, let's see what we get. So it has in fact, remembered everything. So it first remembers that the human asked New York and the AI predicted the Hamptons. Then when the human asked New Delhi, the AI predicted Rishikesh. So this is indeed your memory buffer. Now that we have all of these working pieces of how to interact with the LLM models, how can we stream it? So the easiest way would be to stream it on the Streamlit app. This is an application which is great for your proof of concepts, but you might want to try something else using React.js, which is far more advanced. But for today, we will be sticking to the Streamlit app application. And in order to do that, I have created, one second, where's my terminal? Okay. Yeah, this is the demo. Okay, I have for that, I'm going to create a new directory called the Getaway Planner, which will hold my app. And let's just go to the Getaway library. We do need the registered API keys from OpenAPI. So I'm just going to copy that over. Registered keys over here. And then we will, okay, I am going to be working on that on my Visual Studio Code. So here is my Getaway Planner. I'm going to create a new starter script. So my starter script will look like something like main.py. And this is the script that I'm going to be calling using the Streamlit library. And in order to do that, I am going to first import the Streamlit library, which is just import Streamlit as st. And okay, so let's think what we want on this Streamlit app. Well, we definitely need a title. So what we can do is we can create a title like this, which will be just like Getaway Planner. Then we want the user to input the place that they're at and the number of days they have for a holiday. So what that looks like in the Streamlit app is st.input text. So this is definitely going to be a text in both cases. Enter the city, which will be the command for the user. We can also have like a placeholder giving them an example. Placeholder is equal to example San Francisco. The other thing that we want is the number of days. So input text, enter the number of days, placeholder is equal to example. Okay, now that we have that, we want a way to create like a button of sorts so that the user can click it and get the itinerary. So we can give this button a name, which is st.button and generate itinerary. So the way in the Streamlit app that we see if the button is clicked is just to get a response. If the button is clicked, it's just going to say true. So we put an if. If the button is clicked, we want to check that the cities and days are set. So we do if city and days. If the cities and days are not set, we will throw an error. Please mention the city and days. But if the cities and days are set, what we want to do is just convert the days into an integer. We're not worrying too much about like the exact formatting right now. We can make this code way more sophisticated later, but we're just doing that. Now that we have the cities and days, we've converted the days into the integer, we want to convert this into an input that we can pass to the LLM. So if you remember, the input was something like a dictionary. We're just going to do that. In fact, just going to copy paste that. For now, we can also just, honestly just copy paste the entire block over here. Oops. For now, we don't have an LLM for the first round, so we're just going to hard code the result. So the result is going to be destination, and that will be Hawaii. And the itinerary will be TBD. Oops. Okay. And instead of printing, we actually want to display it. So the way we display things in Streamlit is by different things. Like we can mention one thing could be a header, a subheader. But we want the destination to be a header. So let's just copy paste that as a header. And the rest of the itinerary could just be like text. So we can do that. And pretty much get rid of the print statements altogether. So we have our first skeleton Streamlit app over here. Pretty simple. How we run this is that we go into this directory where it is, Gateway Planner. We do Streamlit run and the starter script, which is your main.py. And once again, it should just load onto your browser. Okay, there is an error over here. Let's see what this error is. Input, oh, text input, sorry. It's not input text, it's text input. My bad. Text input. Okay, and we can just rerun it over here. Now, if we try to generate the itinerary without actually specifying anything, it will throw the error. But if we do say that we want to go somewhere, right now it's just going to say Hawaii and TBD because that is the hard-coded thing that we put in. So how do we actually remove this hard code and plug it in from the LLM APIs? That is also pretty straightforward. For that, I'm going to abstract that code out over here by creating a new library saying import LLM API. And that's just going to be a new file over here, LLM API.py. What this is it's a library that will store all the code that we've been working on so far that kind of prompts the LLM models. And in this library, just like before, we are going to first register the API key. And if you remember, I have kind of copied over the registered keys over here as well. We then want to import the rest of the libraries that we've been using today. A recap on that would be we've looked at the OpenAI model, then prompt templates, LLM chains, sequential chains. We're going to use all of that. We then create our model just as before, LLM OpenAPI model. And once we have that, we're essentially just going to look at the last demo and copy paste everything that we've done from here. It's pretty straightforward. Just copy everything. And this final E2E chain is what is going to give us our final result. So the way we call that final E2E chain is we can remove the hard-coded result is now we're going to call it from the LLM API library. Now, when we go to the Streamlit app and we rerun it, it's going to take some time because it's kind of connecting to the LLM APIs. And okay, this time when it's, let's say it's asking for a 10-day itinerary from San Francisco, it should actually generate an itinerary near San Francisco. Lake Tahoe, great place. But one thing that you want to notice is that it can only do 8 days and not 10 days because currently ChatGPT 3.5 has like a limitation on the number of characters it can output. We can change that, but a quicker way just for this demo would be to change the prompt a bit, which would be suggest the names of places, only output not. Let's see if this works. Rerun. And there we have it. So it's just outputting the names of the places for the 10 days. So let's recap on what we've seen in the demo today. In today's demo, we saw a history of language models and saw how LLMs are working and saw the importance of attention in LLMs. We set up our OpenAPI and prerequisites, understood the different parts of a prompt, looked into prompt templates and chains, and worked with buffer memory. For this demo, we didn't need to use buffer memory right now, but as we build upon it, we would need to use buffer memories. Finally, we tied it all together and hosted it on the Streamlit. Just before I go into the Q&A of this session, I would want to touch upon a few things. So like I said before, all the code is here already on this GitHub repo. Please do look at it. Create issues to ask me questions. I will update it. If you don't have a GitHub account, or if you have like general inquiries that you want to ask about, please ask them at Meetup and I will answer them over there. And the organizing team will also answer it over there. For the next session, what we want people to do is to start thinking about your applications. And the next session is going to be on July 8th, I believe. And so by July 2nd, think about your ideas, start working on your ideas, start building like a skeleton, and if you're interested in coming back, definitely give us a written paragraph about your idea. I'll go through all of them and give suggestions as well, but I will select like a few of them so that they can be displayed in the next workshop, and we can have like a peer feedback like session and really kind of connect with everyone who's here, and that would be great. And having said that, I would like to open the floor for questions and answers right now. I think we have like 10 minutes, so that's awesome. And if I'm not able to answer any question here today, I have linked a page where I will go through all your questions and answer them in detail offline as soon as possible. Having said that, let's go through your questions. Where's the Notion link? Okay, so the Notion link is going to be there on the slides that we're going to share, and it's going to be coming with you through email, the email that you registered with. And the GitHub link is also going to be there. Okay, and Kevin's already added that. I would love to learn how we build intrinsic safety mechanisms. Okay, I will definitely have a look and try and add that into the next information workshop. In the transformer model, are the weights in the table based on how closely two words or phrases appear together? That is one consideration, but there are multiple other considerations as well. It's not just on the proximity. Sometimes, like based on your training data, you have certain words and frequency, certain words which have greater frequencies or which have traditionally been shown to have more importance based on backpropagation and learning. So that also impacts, and there's several different things that impact the weights, but that's definitely one of them. John Dickman is interested to learn how he can build an intrinsic safety mechanisms. I'll definitely touch upon that. In the website that was shown during the introduction, I noticed a caption that was mentioned that there's an initial token. Okay, so it says in the website that was shown during the introduction, I noticed a caption that mentioned that there was an initial token budget of $5 in the OpenAI API playground. I have already played around in the API playground, but I never got my initial budget. And to this day, I haven't been able to test any of my bots. Is this initial budget a new concept, as in within the last 2 months? Oh, okay, you have the $5 budget. Great. So, yep. And somebody also mentioned that the Google Cloud gives $300 budget. That's true. And you should definitely check that out. Yes, I do go through some of the steps a bit fast. I'm sorry for the because we were short in time, but we will be sharing this recording out. And if there's any part that's unclear to you, please definitely reach out and I'll be more than happy to explain it again. So I'm currently stuck on the part where I'm supposed to get the API key. I reloaded the page a few times, but I simply cannot obtain the API key and it keeps throwing an error and instantly reloads the page. I will check this out because I haven't come across this error so far, but I will check this out. I will, I'll mark this and check this out. Is she showing us how to build a wrapper code using ChatGPT as an engine to build a specific application? Yes, that was the intention, that I am trying to build a traveler planner app, and that is a wrapper around the ChatGPT API. Yes, I will be touching upon explaining how to build agent in the future presentation. So once we have the RAG framework and basically for the agents are like a natural evolvement of RAG, like the next step. So once we have the RAG into play, we will touch upon agents and even touch upon multi-agents because that's something that I'm really curious about these days. So you can definitely look out for that. There is one question which I don't have the answer to right now, which is I have been hearing some discussions of CPU, TPU, and GPU in context of AI applications. Is there a particular difference we should pay attention to in AI landscape? Can we deploy applications across all of them? Or is there a particular difference between these architectures that we should be familiar with? So I do not have a great answer to this, but my general understanding is that LLMs, so basically CPU, GPU, and TPUs have different amounts of compute capacities. For instance, if you run an application on CPU versus GPU, it's going to take a lot more time on CPUs because a CPU is just not built to run models, train models. It doesn't have the capacity or the parallelism as opposed to GPUs and TPUs. So while you may be able to run these applications on all three kinds of compute, the time that it takes to train and everything is vastly different. And honestly, like trying to train like a heavy model on CPUs is just not going to work. That's all the questions I see right now. I think I've covered most of the questions, but as before, please keep asking questions. And yep, I hope to talking to you soon.